Good. 6 of you got it. Good. Excellent. To just quickly refresh the memory. Whiteboard. Of anybody who didn't get it. Our equation was 2Sb solid plus 3 sulfur solid. Good luck getting these solids to react. Sb2S3 solid. And we started with 1.73 grams of the antimony, excess of this. And first you need to find the theoretical yield. So that's the first step. It gave you the actual yield. So if we have 1.73 grams of our antimony, those of you who got this right must have used the molar mass. I got the molar mass of antimony is 121.86 grams in 1 mole of antimony. Remember, the molar mass is always per 1 mole. That's what you use. The coefficients here are used for the mole to mole ratio. So once I had my moles of my antimony, then I can do the mole to mole ratio. I get 1 mole of Sb2S3 for every 2 moles of Sb. This is coming from so 1 here, there's a 2 here, or my mole to mole ratio. Now my moles of antimony have canceled, and I can use the molar mass of Sb2S3, which I got as, 217.97 grams of Sb2S3. Oh, I think I got that wrong. I didn't multiply by 2. 121.86 times 2 equals plus 30 times 30. I think it's 339.84. Sorry. 339.84 grams of Sb2S3 for every 1 mole of Sb2S3, if I calculated that right. My moles cancel. And this gives me, I'm not going to do the math, my theoretical yield. I don't really know. I didn't do the math to figure out that number. You were given that the actual yield is equal to 1.40 grams. So divide the 1.40 grams by this theoretical yield, multiply by 100, and I'm going to assume we get 58%. So this is the quick using molar mass to get moles, then mole to mole ratio, and then molar mass to get back to grams. We have about 8 more questions. It is now 7:30, but I can keep going if you guys want to keep going. I know that you have limited time, you might not, but I will go on to the next one. Can you tell us which pair of molecules? This would be a Lewis structure one. You can almost guess on this one if you know just a couple of things. Oh, okay, Megan, you said you're good to keep going. All right, we will keep going. All right, I think that's all of us. So good, 4 of you picked this one. I won't go and think and, okay, good, several of you can stay. So I'm not going to go and draw these out, but I'll just tell you some hints. Okay, so we have, over here in the red, we have sulfur dioxide. Sulfur is in the same group as oxygen. If you think about oxygen, when oxygen is bonded to 2 things, what is the shape of oxygen? Sorry, what's the shape of the molecule when oxygen is bonded to 2 things like hydrogen, like water? What's the shape of water? Bent, exactly right, Jay. So because sulfur is in the same group as oxygen in the periodic table, so here is sulfur right under oxygen in the periodic table, you can expect it to have a similar shape. So that means SO2 is probably bent, but we should hopefully remember CO2 is linear. So toss out the red one. Over here, the same thing. We have oxygen bonded to 2 fluorines. It's going to have the same shape as oxygen bonded to 2 hydrogen. So it's bent and carbon dioxide is linear. That one we can toss out. Phosphorus, we just said that, that nitrogen bonded to 3 things is a trigonal pyramid, and phosphorus is right under nitrogen. So if it's bonded to 3 things, it's going to be a trigonal pyramid. If you remember that boron always is trigonal planar, then you will know that PH3 and BF3 are not the same shape. It helps to, you can figure it out, but it helps to remember that boron is always trigonal planar, or at least for general chemistry purposes, which leaves SO2 and O3 as the only possible answer. But you could prove it by doing the Lewis structures. That was just to try to help you think things through if you get in a hurry on the exam. What's the percent by mass of oxygen in calcium nitrate? Molar mass of calcium nitrate is 164. right. That's everybody. Oh no, don't. Aw, shucks. Sorry, I missed it. Well, sorry. The way you did this, so it was, so how many oxygens? It was calcium carbonate, right? How many oxygens are in a, it was what was the compound? It was CO3 Was it sodium carbonate? Yeah, it's 6. Sorry. So I don't know what the compound was. I accidentally hit the wrong thing. Nitrate. Oh, that helps. Okay, thank you, Megan, very much. So it was calcium nitrate. So yes, there were 6 oxygens in calcium nitrate. And so we would take those 6 oxygens, multiply them by their molar mass, which is 16. So 6 times 16, and then divide by the molar mass of the compound, multiply by 100. So that's the way you do that. However many oxygens, count them up. Use the molar mass of oxygen, which is 16 grams per mole. Multiply by the 6 that you have and divide by the molar mass of the whole compound. I've got to be careful. Oh yeah, this one I didn't know. This is going to be a 20-second one. So if you don't know it, it's no great loss. CaO. What is the name of that? Calcium oxide. 5 more seconds. And it is quicklime. You guys know it. Good for you. I didn't know it the last time we did this. Which compound would be expected to have the largest dipole moment? It helps to know the shape. Oh, yeah. This is a good one. Maybe give it about 10 more seconds and we'll do the answer. There we go. Oh, we didn't have too many people get it right. So maybe I'll do this one. CO2, BF3. What do most people say BF3? CF4, that one's hard to draw. And SO2. All right, so come over here. Whiteboard. Oh, somebody did a smiley face. Okay, so we have CO2. We've been saying that CO2 is linear. You can see how much I pay attention. Yeah, there it is. It's back again. That's good. Okay, so remember for dipole moment that you have to have, it must be unsymmetrical. So is the CO bond polar or nonpolar? Is the CO bond polar? It is polar, right, Megan? But they're pulling in opposite directions. So oxygen is more electronegative than carbon, so it pulls this way. But this one pulls exactly equal and opposite in the other direction. So is carbon dioxide polar or nonpolar? It cancels out, right? So that means it's nonpolar. Exactly right. And then another one is BF3, and BF3 looks like this. It is, I mentioned a moment ago that boron is a trigonal planar. All of these outer atoms are, I didn't put my lone pairs on. There are no lone pairs on the boron, they're only on the fluorine. They all pull equally in 3 different directions. It is very symmetrical. And here, just as Jay said for carbon dioxide, the bond dipoles cancel. So this is non-polar. Another one is, what was this one? CF4. Oops. CF, to try to do this. F, F. What's the shape of CF4? Anybody know the shape? 4 bonds around carbon? Tetrahedral. Tetrahedral. And so all of these angles, every single one of the angles you can draw are 109.5. Is that symmetrical? Yes or no? Yes. If it cancels out, it's nonpolar, Stephanie. Yes. Correct. So I know my artwork is atrocious, but do you think this tetrahedral molecule with 4 identical atoms on the outside is symmetrical? Is symmetrical, yes or no? You can answer, it's a 50% chance you get it right. It is. It actually is a yes. It's very symmetrical. So all the bond cancel. So trigonal planar, symmetrical. You can generally, at least most of the time, if you have no lone pairs on the central atom, and no, Jay, I don't think you won't have access to it. I don't think so. So no lone pairs on the central atom. All the outer atoms are the same. That's nonpolar. That's most of the time. So that leaves our SO2. And SO2, we talked about it should be like oxygen. Sulfur should be like oxygen. So there should be 2 lone pairs on the sulfur. I can't remember exactly the structure, but I think this is it. But this is bent, not symmetrical. And it has these lone pairs, which makes it not symmetrical. So that, the only molecule with a dipole moment at all in this group is SO2. lost my music. Music died. Got tired of music, I guess. All right. Which type of hybrid orbital? Oh, do you guys remember that? Which type of hybrid orbital is used in CO2? The shape tells you. Actually, it's the electron cloud shape. The electron group, the electron, however many electron groups you have. Oh, 10 answers, you already got it. And 3 of you got it right. So if it's linear, so if it's linear, carbon dioxide has 2 electron groups. I feel like I need to draw it. Explain it decently. I need a picture. There's CO. I won't erase it. I'll just get another color. We'll do green. Okay. So CO. All right. So carbon has 2 electron groups, and so that means it needs 2 hybrid orbitals. sp is made up of an s orbital and a p orbital, and so that's 2. It took 2 atomic orbitals, 1 s and 1 p, in order to make the sp hybrid orbital, and so you need 2 of them. So if you have sp, yes. If you have an sp orbital, that means you get 2 of them, and so if you have 2 electron groups, then you have an sp orbital. Yes. And Megan asked the question. Yeah, BF3. So BF3 that we have right here, it has 1, 2, 3 hybrid orbitals. It needs 3 of them, so it needs to be made up of 3 atomic orbitals. So sp2 is made up of 3 orbitals, 1 s and 2 p. And this CF4, CF, F, F, and F, we need 4 hybrid orbitals. So if I have sp3, I have an s and 3p. That's a total of 4 atomic orbitals that will make 1, 2, 3, 4 hybrid orbitals. And just to mention, ammonia, also sp3, because that's a hybrid orbital, that one, that one, that one. So I need 4 hybrid orbitals, and that's what I get with sp3. You get 1s and 3p equals 4 total orbitals. That was a really quick, I know, but that was the quick and dirty explanation. And if you need more answers, you can ask me about it. All right, 30 of 32. What metal can you melt by holding it in your hand? This is a quick one. You may or may not know this. So, yeah, 9 answers. That's good. One more. We got it. It is gallium. Gallium is one that melts in your hand. It's a solid at room temperature, but stick it in your hand and it's going to melt. What's the oxidation number of sulfur in SO4 2-? Yeah, mercury is already a liquid. Coins are not made of gallium. That would be a problem. Our hot little hands would melt it. That would be a good reason not to make it of gallium. It's got nickel. I know it's made of, I know there's a lot of nickel in money. Coins. 10 answers. Let's see what if we got it. Oh, 5 of us got it. Yeah, very good. SO42 minus, we can do this one pretty fast. So we have SO42 minus, which means the sum of all of our oxidation numbers has to equal -2. And so I do this, I do it with this little math problem. And my sulfur goes with this pair and my oxygen goes with this pair. In my first parentheses, I put how many I have. I have 1 sulfur and I have 4 oxygens. Which of these do I confidently know the oxidation number of? Sulfur or oxygen? Yes. And Megan, what is the oxidation number of oxygen? Yes, Samantha. Oh, no, not in a compound. Only, oh, you wrote, no, I see you did it. Yeah, I got it. I see what you did, Amelia. Yeah, yes. So, yes, so the oxidation number of oxygen is -2. And so I'm trying to solve for sulfur, so it goes there. 1 times sulfur is S, plus 4 times -2 is -8, is equal to -2. Add 8 to both sides. I have sulfur is equal to +6. So the oxidation number of sulfur and sulfate is +6. We just have to be sure we set it equal to our charge. Good. And so I want to do this. Go here. We have 1 more. We're almost there, folks. Ha! Funny. Okay, that's everybody. Yay, Marie Curie did. Exactly right. Marie Curie won 2 Nobel Prizes, not something like 1900.